Global warming in geological time is a natural event, and we know quite well that we go through big swings and roundabouts, and the classic swings and roundabouts are we go into an ice age and then a warm period.
There's these little phytoplankton that live in the water, and they make two compounds and they change how many of each in response to temperature. They give us a nice correlation with temperature. We've done a lot of paleo work. We established that the sea surface temperature of the Southern Ocean was about 4 degrees cooler in the last ice age.
We were drilling into the seabed. The seabed was 4,500 meters below us, and we were right in the path of the Antarctic circumpolar current, this huge current system which sort of encircles Antarctica and is one of the reasons why Antarctica is cold. And here I was in the middle of it, drilling into the seabed. We got the cores back, which was sort of a time capsule of how this vast current system is operated. I remember it quite distinctly. It was so exciting for me. Here we were seeing a record of how the current switched on, switched off, switched on, switched off. The current was obviously changing quite dramatically. And going back, some of the cores went back to 33 million years ago. We see the onset of this major current system.
On the kind of long time scale in the natural cycle, the ocean is often in the past been what drives atmospheric carbon dioxide concentrations, and thereby what drives the climate changes that they cause. We've slightly turned that on its head by adding carbon dioxide into the atmosphere, and we'll now watch how that interacts with the ocean.
When I look at the carbon dioxide record, those big swings and roundabouts have taken place within an envelope of something like 300 to 120 parts per million carbon dioxide. Right at the moment we're 387 parts per million, and we're way out of our comfort zone.
When we've seen these kind of climate changes in the past, they generally come with mass extinction events and huge loss of life and biodiversity. And I guess the particular concern for us is that that massive loss of life could be our own.
I've been looking at the timing of these cold periods, warm periods, and quite often the very high frequency events, the events that occur quite rapidly around the world, they tend to lead from the southern hemisphere. In other words, they start off in the southern hemisphere and then the northern hemisphere responds a little slower. What we see now is something quite unusual. Everything is forced from the northern hemisphere. The northern hemisphere is heating up far more rapidly than the southern hemisphere. So we've seen a change in the natural timing of these climatic shifts. That, with the rapid changes in CO2, that with the rapid environmental changes we're seeing now, particularly at a time when something like 40% of the world's population lives within 100 kilometers of the coast, those sorts of things are starting to bite home. Yes, we definitely are in a period of global warming. Yes, that global warming is unnatural in the sense that there's a strong human imprint on it.
We've been out for about nearly 6 weeks now, so it's starting to feel like a long time. Just a few days ago, we weren't able to recover the mooring because of the fog and then the bad weather the following day, and I guess that's just part of the job. You've got to be a little bit patient.
I love my work. I suppose I shouldn't say, but I've been doing this for almost 20 years, and I really enjoy coming out to sea. Even getting seasick doesn't stop me. I get seasick a bit, but it's what makes being an academic fun. I spend a lot of time at my desk, I spend a lot of time in the lab, but coming out here is a change. You cannot do the science without knowing where your samples come from. You can ask people to bring you home samples, but if you don't actually see where things are coming from, it's easy to miss the subtleties in what you're looking at.